All right, people, here we go. Number nine, toolkit number nine. We're talking about describing functions, and this is part one. And we have a function here, and I'm gonna add in some arrows here to show that this goes forever. I made them blue, but I want to match. I feel bad. There we go. All right. Oh wow, that did not doesn't look great. Sorry. All right, here we go. Interval notation. Interval notation you've probably learned before. If not, well, you're going to learn now. So this is great. Interval notation tells us where x values start and end, and if end points count. And I'm going to put count in parentheses, right? So sometimes endpoints count. They're part of the solution or they're part of the region, right? Sometimes they don't. It starts right up next to it. So we don't start at 4, but we start at 4.00000000001, right? So just to the right of it. But 4 doesn't count. But right next to 4 does count, right? So remember like an open circle or closed circle. That's kind of what we're talking about here. Okie dokie. So the way interval notation works is we'll give you just some example. Okay, so boom, boom, put a parenthesis or a comma in between. That's a comma. And if I say 3, 5, this tells us that we go from interval from, I guess it doesn't always have to be X. It could be X or Y values. Interval from 3 to 5. So all the way from 3 to 5. That's the interval. And then both endpoints count. Okay. This would be like a filled in circle on a number line. Okay. Negative infinity to positive infinity. We've seen these before, even in this class, I think. We'll see, maybe. All right. So this one, the interval goes from negative to positive infinity. Basically all real numbers, right? This is another way to say all real numbers. And neither endpoint can be reached. All right, we can't get to infinity. Neither endpoint can be reached. Cool? Cool. So this is how you read it. We're going from here to here, and these tell us if they count or not. Bracket, it counts. Parenthesis, it doesn't count. Okay, the endpoint doesn't count. The endpoint does count. Cool, cool, cool. All right. So that being said, let's jump into this example right here. We are going to describe this little function right here. Beautiful. It's probably a little quartic equation, y equals something, x to the fourth, plus some other stuff, right? There it is. Each box equals 1 unit. That's nice. So we have some numbers there. Here's all the things we're going to talk about. Domain, range, where is it increasing? Where is it decreasing? Where are the x-intercepts? Where are the y-intercepts? That's it. Okay. So what I like to do is kind of give it an eyeball. Okay. Imagine you're on a roller coaster and you jump on the roller coaster and what's happening? So there's kind of a low point here, right? And then we go up, kind of a high point there. And then we start going down again. And then we hit a low point and then we kind of go up. So I get a feel for what's happening first. All right, so let's jump in. Domain is what X values are possible. Okay, so what X values are possible? So what I like to do is I kind of start in the middle and I go to the left. And I go, okay, it's like X value is going to negative, negative 3, 4, 5, 6, 7, 8, 9, 10. And then this is going off and it's going to get higher and higher and higher. But does it continue to go forever this way? It does, right? It really does. So this is going to continue to go up, but it's also continuing to go out forever. Well, what about on the right side? Yeah, same thing, right? It's going to go to the right forever. It's also going to go really, really high. Okay, so because it goes to the left forever and the right forever, where does it start? It's going to start at negative infinity and it's going to go to, oops, sorry. It's going to start at negative infinity. It's going to end at positive infinity, although it never ends. And when we talk about infinities, because we can't get there, we're going to, with our interval notation, do that. Okay. We could also say things like all real numbers. We can do the fancy R. Um, yeah, cool. All right, range. Range is what Y values are possible. Sometimes when we talk about domain and range, we also kind of just say what it can't be, because sometimes there's certain things that just can't happen. So we just say X cannot be 4, and then we just assume that everything else is cool. Okay. In this case, what Y values, that's a Y, not written very well. What Y values are possible? So again, I'll start at 0 and kind of go up. There's Y values here, and it looks like Y values go to infinity. So Y values are heading towards infinity, so they go forever. But what's the lowest Y value? Let's go. That's pretty low, but then it goes back up, and here it gets lower. So that one's all the way low. And remember, each box was 1 unit. So this is -1, -2, -3. So it must be -3 and above, right? So we start at -3, we go to positive infinity. Oops, there we go. So we start, lowest value for Y is -3, and then the highest value, oops, somebody's calling me. That's great. Goes to positive infinity. We can't get the positive infinity. And this one looks like it does get to -3, right? A lot of times I might give you a point. I might go, this is -3 comma -3, right? And then you'll know for sure that it gets to that point and it includes it. If I didn't, I would probably be okay with you doing either one here. Maybe it reaches it, maybe it doesn't. I don't know, right? So this one looks like it does get there. So we're going to go solid and say that -3 is the lowest that it can get to. Cool, cool. All right. For increasing and decreasing, okay, we are going to get on a roller coaster. And the roller coaster only goes from left to right. And we're going to ride that roller coaster and say what's happening. All right, so let's go up here. The very left side, the farthest I can go on this one is here. So let's get on that roller coaster. All right, here we are. I put my hands up always. Yay! There we go. Yay! We're going, what are we doing? We're going down, right? So is that increasing or decreasing? That's decreasing, right? So we're decreasing from negative infinity all the way here to about -3. X equals -3. We're going to kind of estimate this. I know it's not perfect. Sorry, but we're going to call it close enough. All right. Then what happens? We hit the bottom and what? We go whee, whoosh, that feeling of all those G's hitting, right? G forces as you go back up, and that is increasing. We hit the top here, and it's like, whoa, oh, and then we go over the edge and we're decreasing again. And then we hit this low point and then we blast off. We're increasing. Okay. So key is always left to right, right? Because if you started right to left, this would be decreasing. So we have to have a standard, right? Kind of like in our country, you drive on the right side of the roads. I had to think about that for a second, right? So for describing functions, we always go from the left to the right. So we're decreasing from here to here. We're decreasing from here to here. We're increasing from here to here. We're increasing from here to here. Okay. So let's write the definition. From left to right, you're going, increasing is going up. This one is from left to right, we're going down. Oops, there we go. There's also increasing, decreasing. There's also a chance that we could be going constant. So that means you're not going up or down. So sometimes there will be, we'll add constant in by the end of this year when we get to calculus. This is, just so you know, this is going to be a big part of calculus later on, especially in our second semester. We're starting it now. We're going to kind of get used to describing things, but it's going to be really helpful when we start doing calculus. Okay, to be able to look at things and find mins and maxes and increasing and decreasing and all that kind of stuff. So this is pretty important. All right, describing the above example. So where are we increasing? From about -3 to 0. So I'm going to say increasing from -3 to 0. I always do not inclusive endpoints because at the bottom, like, does it count or not count? I just say it doesn't count. That's pretty standard. The other place where it's increasing is from here to infinity. I'm going to call this 2. I know it looks like a little bit more than 2. Um, I'm just going to make the dot bigger and call it 2. And that goes till infinity. So 2 until positive infinity, 2 to positive infinity. And again, I don't count the endpoints on these. If you counted the endpoint here or here or here, I wouldn't mark you wrong. This one has to be a parenthesis, but these could probably be either. All right, decreasing. We're going negative infinity all the way to -3. Again, we report the X values, okay? The domain, okay? Let me write that in here. Report the X values, not the Y values. We're reporting the X values, which is the domain, okay? So we're talking about from here to here, we're decreasing. From here to here, we increase. From here to here, we're decreasing. From here and above, we're increasing. Does that make sense? When they ask for increasing and decreasing, it's what parts of the domain would be. Okay? So we don't talk about the Y values here, although we're looking at them. Okay? So decreasing from negative infinity all the way to -3. And then also decreasing from 0 to +2. Okay, again, I'm estimating. All right, good stuff, good stuff. All right, x-intercepts, we know this. Where does it cross the x-axis? I'm not going to spend too much time on that. It can cross more than once. Y-intercept, it could cross 0 as well. Cross the y-axis, it's either 1 or 0 for that one, because it's a function, right? It can't cross twice because then it wouldn't be a function anymore. So for this one here, do we see where it crosses the x-axis? Right about here, right? It looks like about -4. Here, -1.25-ish. Here, +1.25. And then here, we're pretty close to 3. So I'm going to say xints at, what do we say? -4-ish, -1.25, +1.25. You don't have to do the positive sign there, but I did. It's just a little less than 3. I'm just going to call it 3. I'm going to say at about. Okay. Sometimes we might give you what these points are exactly. I might say 3.9 comma 0, right? And then you'd be like, oh, that's 3.9, right? But if it's an estimate, I'm fine with you just getting close, right? Use your best judgment. All right, y-intercepts, there's only one. Okay, it's right here. That's like 1.25 maybe. Y-int at 1.2 at about, because I'm estimating. That's it. That's it. Describing functions. Sometimes these can be challenging or we forget, right? Domain, x's, range, y, increasing and decreasing, right? It's our roller coaster. You got to go left to right, and we're talk about x values only, not y values, right? We don't care about the y values. It's what x values as you travel along them are things going up. Okay, that's key. X values. X values. Why do you think I talk about that? Because there's a lot of people. They would say it's decreasing from positive infinity down to -3, right? But no. Yeah. Anyways, that's it. Peace out.